How small can the universe get? Ever heard of Planck length? Let's dive into the fascinating realm of the infinitesimally small. The Planck length, named after physicist Max Planck, is often considered the quantum of length. It's the smallest measurement of length that still holds any meaning, and it plays a crucial role in our understanding of quantum physics. Now, how small is it? Well, it's derived from fundamental constants of nature, including the gravitational constant, the speed of light, and Planck's constant. You might be wondering just how this relates to our everyday world. To put it into perspective, if a particle or dot about 0.1 millimeters in size, the smallest thing the unaided human eye can perceive, were magnified in size to be as large as the observable universe. A Planck length would be roughly the size of an actual 0.1 millimeter dot. From the smallest, let's step up a little. Ever wonder how small a quark is? To answer that, we need to delve into the realm of the microscopic, where the fundamental building blocks of matter reside. Quarks, my friends, are the tiniest of these blocks. They're so small that they're dwarfed by the Planck length, the smallest length that has any meaning in physics. Now imagine a speck so tiny that it's about 1/100th of a billionth of a billionth of a meter. That's the estimated size of a quark. A size so minuscule it's way beyond our everyday comprehension, but don't let their size fool you. These tiny particles play a colossal role in the grand scheme of the universe. Quarks are the essence of protons and neutrons, those larger particles that form the nucleus of an atom. Each proton or neutron is made up of 3 quarks. But the fascinating part is, even though quarks are incredibly tiny, their collective presence gives protons and neutrons their mass and charge. So how does a proton compare to a quark? Well, if a quark is as small as a speck, then a proton is like a grain of sand, 1,000,000 times larger than a quark. And yet, even the size of a proton is infinitesimal when compared to the size of an atom. An atom, as you might recall from your chemistry class, is mostly empty space. The nucleus, where protons and neutrons reside, makes up only a tiny portion of an atom's volume. The rest is the electron cloud, a vast expanse where electrons whiz around. If we were to scale up, an atom is to a proton as a cathedral is to a marble. In perspective, if a proton was the size of a marble, then a quark within it would be the size of a dust particle, almost impossible to see with the naked eye. And so, as we climb up the ladder of the universe's size scale, we realize that even the smallest of particles have a significant role in shaping the world as we know it. Moving up the scale, let's consider something we're all made of: atoms. Atoms, those tiny building blocks of matter, are incredibly small. So small, in fact, that it takes around 7 million of them lined up side by side to match the thickness of a single human hair. But despite their minuscule size, atoms are far from simple. An atom is composed of a central nucleus, made up of protons and neutrons, surrounded by a cloud of electrons. The nucleus is so tiny that if an atom were the size of a football field, the nucleus would be a tiny speck, no larger than a grain of rice at the center. The rest of the field would be the electron cloud, a space filled with energy but mostly empty. Now, let's imagine an atom in relation to a human cell. Cells, the basic units of life, are composed of billions of atoms. To understand the size difference, think about the fact that a single human cell could contain more atoms than there are stars in our galaxy. The structure of a cell is as intricate as it is vast on an atomic scale. It's like a bustling city with different parts performing different functions. The nucleus, akin to the city hall, contains the genetic material that dictates the cell's activities. The mitochondria, like power plants, generate the energy the cell needs to function, and the cell membrane, acting as the city's walls, regulates what goes in and out of the cell. But how does a cell compare to a human being? Well, just as a cell is a metropolis of atoms, a human body is a universe of cells. Each of us is made up of approximately 37 trillion cells, all working together to make us who we are. So here's a thought to leave you with. If we were to scale an atom up to be the size of a stadium, then a human cell would be as large as the Earth. From humans, let's leap to the stars. How big is our home, the Earth, compared to the universe? To begin, imagine our home, the Earth. It's approximately 12,000 kilometers in diameter. That might seem large, But let's think bigger. If an average human standing 1.7 meters tall were to be the size of our planet, then the Earth would be a mere speck, about as large as a pea. Now let's leave Earth and venture into our cosmic neighborhood, the solar system. If Earth were the size of a pea, our solar system, including all the planets and the Sun, would stretch over 25 kilometers, nearly the length of a marathon. Quite a hike, isn't it? But oh, we're not stopping there. Let's now journey to the Milky Way galaxy, our galactic home, teeming with hundreds of billions of stars. In comparison, our solar system, that 25-kilometer marathon, would be no bigger than a dinner plate. The Milky Way itself would span over 100,000 light-years, an almost unimaginable distance. Yet even the Milky Way is but a tiny speck in the grandeur of the observable universe. If the Milky Way were to be scaled down to the size of a coin, the observable universe would stretch over 93 billion light-years. This universe, our universe, is home to at least 2 trillion galaxies, each brimming with billions of stars, just like our Milky Way. So let's revisit our original question. How big is our home, the Earth, compared to the universe? Well, it's almost unfathomably small. To comprehend the vastness of the universe, if the Earth were scaled down to the size of a marble, the observable universe would be larger than the size of the planet Jupiter. We are but tiny beings in an unimaginably vast cosmic ocean, and yet it's all part of our home, the universe. We've journeyed from the smallest scales to the largest. But how do they all compare? Let's take a step back and appreciate the vastness of the universe's size spectrum. We began with the Planck length, a scale so minuscule it's almost beyond comprehension. Yet, that's where our journey started. From there we moved to the realm of quarks, then protons, and then atoms. Each step up in size is a leap into a new world of complexity and wonder. As we continued to zoom out, we reached the human scale, where we interact with the world every day. Further still, we ventured into the cosmic scale, where galaxies, clusters, and the observable universe itself reside. Each scale, from the Planck length to the observable universe, is a testament to the incredible diversity and enormity of the universe. So next time you look up at the night sky or down at your own hand, remember the incredible scales of the universe, from the tiniest Planck length to the vast observable universe.